Hi, lovely children. You are welcome to Basic 3 Mathematics. We are still on numbers, and then it is still number operations. So by the end of today's lesson, you should be able to represent and explain multiplication using rectangular arrays. You should be able to represent and explain multiplication using rectangular arrays. Good. So we move on to our keywords. The first keyword we have is vertical. So vertical refers to an upright structure. So when something is upright, we can say that it is what? Vertical, such that the top is directly above the bottom. So an upright structure where the top is directly above the bottom. So I'm taking my arm for example. So this is the top, this is the bottom. It is upright, okay? So I have my arm in a vertical position. So vertical stands upright like this. Good. Now we have horizontal. Horizontal is to have the same level of a line. So we draw a line from left to right this way, or we can still use the arm. So from this section to that section, we can say that it is in an horizontal way. So to have the same level of a line, they are in the same level. Good. That is horizontal. Now we move on to intersection. So intersection is a point at which two or more lines intersect. That is join or meet. So when we say intersect, it means to join or to meet at a particular point. So intersection is where lines meet at a particular point. So when two lines, this is our horizontal line. When I draw a vertical line across it, where does the lines meet? The point at which the lines meet. Good. So they meet here. So this point becomes an intersection. It means that is where the two lines meet or intersect. Right. Our next keyword is array. It is an ordered arrangement of something. So when you have an arrangement of something in an organized way, for example, when I add another vertical line this way, another one this way, and then I put across an horizontal line. So I have arranged the vertical and then the horizontal lines in an organized manner. So this is what we can say, or this is what we mean when we say array or array. Good. So today we are going to look at multiplication and number operations. Last week or in our previous lesson, we looked at different strategies used in addition and subtraction, and then we looked at the property of commutativity. the strategies we have in addition and subtraction are the decomposing, the friendly jumps, changing addition into subtraction, and changing subtraction into addition. And then we looked at the property of commutativity, where we change the positions of the numbers but still get the same result. So for instance, we have 21 plus 22. When we change the positions of these numbers, they should still give us the same answer. So I'm bringing my 22 first plus my 21. So the first one is 21 plus 22. And then when we are using the property of commutativity, we change the positions of the numbers and then give the results. So I have 22 plus 21. Let us add both addition sentences and then check out our results. We have 21 plus 22. So 1 plus 2, what do we have? 3. Good. And then 2 plus 2, what do we have? 4. Very good. So this becomes 43. Now let us add our second addition sentence. We have 22 plus 21. 2 plus 1, what do we have? 3. Very good. And then 2 plus 2, what do we have? 4. That is right. So it's also 43. So that is about the property of commutativity. Changing the positions or orders of the values of the numbers and still getting the same results for both sentences. Good. So we are moving on to today's lesson, which is what? In multiplication. And today we are going to use rectangular arrows to do our multiplication. Good. So what do we do when we want the result for 2 times 3? So in multiplication, we know we use the multiplication sign as this, the times as our multiplication sign. So what do we have when we multiply 2 by 3? In this case, we don't go straight by saying our times table, but then we are going to use the arrays to find our result, that is our answer. So we are going to use our vertical lines and we are going to use our horizontal lines to find the answer for 2 times 3. Good. So this is our vertical line, as we said, from top to bottom. So it stands upright, straight this way. So we have our vertical line. Good. And then we'll use our horizontal line straight like this. So this is the horizontal line. Good. So we are going to make use of the vertical line and then the horizontal line to find our answer for 2 times 3. Now when you see the vertical line is also known as the leg. So whenever you see the vertical line, it is known as what? The leg. So I'll be using that interchangeably. So in most cases, I will say we are using the leg. So the leg is what? The vertical line. And then the horizontal line becomes the arm. So instead of saying horizontal line, I would say that we are using the arm. Good. So we have the vertical line, which is the leg, and then we have the horizontal line, which is the arm. Now let us find out the answer for 2 times 3. So first of all, we'll take the vertical line, which is the leg, and then make 2 of the legs. So we'll draw 2 vertical lines. Very good. We'll draw 2 vertical lines as we have here. And then we look at the horizontal line, which is the arm, for the second number. So the second number takes the horizontal line, which is the arm. How many arms are we drawing? 3 of them. So we have 1, 2, and 3. So we cut across the vertical lines with our horizontal lines, depending on the numbers that we have. So 2 for the vertical lines, and then 3 of the horizontal lines. We'll have to find out the answer by looking at the intersections. And then we said that the intersections are the points where the lines meet. So let us locate where the lines meet. So there's an intersection here. A line is meeting here. Another one is also here, making 2 of them. There's another intersection here. 3. Another one here. 4. And then we have another one, which is 5. And then another intersection here, which is what? 6. So the intersections will tell us the answer for our multiplication. So we have 1, 2, 3, 4, 5, 6. 6 of the intersections. Therefore, 2 times 3, we have 6. Whenever there's a space in between, they are not known as the intersections, because the intersections is where the lines would meet. The lines should cross each other before we can say that it is what? An intersection. So if the lines are not meeting at any point at all, we don't count them, or we don't refer to them as intersections. Good. Let us try more examples using the rectangular arrays. Okay. So we have another example. We have 4 times 5. 4 times 5. We are using the arrows to find our answer, using the vertical and then the horizontal lines. Our first number takes the vertical lines, which are what? The legs. So I'm standing on my legs, which represents my vertical lines, and then my arms are stretched wide open, which represents the horizontal. So the first number takes the vertical, and then the second number takes the horizontal. How many vertical lines are we drawing? 4 of them. So upright, 1, 2, 3, 4. Very good. And next number, which is 5. How many horizontal lines are we drawing? 5 of them. So in a straight across the vertical lines. So we have 1, 2, 3, 4, and then 5. So we have 4 vertical lines, 5 horizontal lines. Let us locate the intersections. The intersections. So where the lines meet. We have one here, another one here, another one, There's another one here, another intersection. Good. So these are all intersections because the lines are crossing each other, or they are meeting, they are joining together at this point. Alright, so let us count our intersections. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Very good. So we have 20 as our answer. Now let us look at it on our times table. So we have 4 times 1 will give us what? 4. 4 times 2 is 8. 4 times 3 we have 12. 4 times 4 we have what? 16. And then 4 times 5 we have 20. So that is about our multiplication. So we are using the vertical and the horizontal lines to find our result or answer for our multiplication sentence. Good. We move on. Okay, so we have our last example. We have 6 times 3. 6 times 3 using the rectangular arrows in finding an answer for our multiplication sentence. Good. So we are using our legs and then our arms. The first number is the what? The leg, which is the vertical lines. And then the second number is the arms, which is the horizontal lines. So we are making 6 of the vertical lines. 1, 2, 3, 4, 5, 6. Good. And then 3 of our horizontal lines. We have 1, 2, and 3. Let us locate our intersections. We have one here, another here. Right. So these are where our lines are what? Joining, or where they are meeting. Good. Let us count our intersections. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So our answer is what? 18. Let us look at it. Okay. 6 times 1 we have 6. 6 times 2 we have 12. And then 6 times 3 we have 18. Good. So this is about our vertical and then our horizontal lines in finding the result of our multiplication sentence. Good. Now we are about to look at another strategy in multiplication using the number lines. Good. So we have our number line this way. Good. We have our number line. And then we need to have a multiplication sentence. So let us take 4 by 3, or 4 times 3. Now let us put numbers on our number line. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Good. Now, our first number is what? 4. We are going to move or count in 4 or jump in 4s. So we stand at 0 and count 4. So this becomes 1, 2, 3, 4. So from 0 to 4. We'll count another 4 starting from the 4. So 1, 2, 3, 4. Another 4. Good. We are counting another 4. We need to get what? 3 of these umbrellas to get to our final answer. So we are standing at 8 and counting 4. So we have 1, 2, 3, 4. So we get to our 12th number. So we have 3 of our umbrellas, and then we've counted in what? 4s, and then we got to what? The number 12. So where we got to shows us that 4 times 3 will be what? 12. I hope that was easy. Let us try another example. Okay, another multiplication sentence. So we have 5 times 3. We are about to use the number line. Let us draw our number line. We started from 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So it doesn't matter the numbers you put on the number line. You can put as many numbers as you want. Good. So we have 5 times 3. We are going to count in 5s. We are going to count in 5s to have 3 umbrellas. I hope that is clear. We are counting in 5 to have 3 of the umbrellas. Good. Let us start from 0. So we are counting in what? 5. So 1, 2, 3, 4, 5. So we have our first umbrella here. Now we start at 5 and count another 5. So 1, 2, 3, 4, and 5. So we are getting to our next umbrella. Now let us count in 5 from 10. We have 1, 2, 3, 4, and 5. Our last umbrella. So which number did we stop at? The number 15. So that is our answer for 5 times 3. Let us look at the last example. Good. So we have 2 times 6, which means that we are going to move in 2s but have 6 umbrellas. Good. So we are starting from 0, 1, 2. We have the first one, and then 1, 2, another 1, 2. Our third umbrella, 1, 2. Our fourth umbrella, and then 1 and 2. fifth umbrella. And then 1, 2, our last umbrella. So which number did we get to? 12. Very good. So 2 times 6 will give us 12. That is about our number line in multiplication. Very good. Now we move on to our last strategy or way of finding answers for multiplication sentence, and that is the what? The skip count or the skip counting. So we are going to skip count and then we look at it in a multiplication way. Good. Alright children, so we are going to skip count in threes. So skip count means that we are going to jump over certain numbers. For example, we are skip counting in threes. It means that our numbers should be in what? In threes. We will add threes to each number. So the first number we have is 3. We are adding 3 to this 3 to get our next number. So when we add 3 to another 3, we will get what? 6. We add another 3 to the 6 to get 9. Another 3 to the 9 to give us what? 12. So this is what? Skip counting. We are jumping over numbers. In this case, we jumped over 4 and 5. Yes, we've skipped 4 and we skipped 5 to get to what? 6. This is also in a way of saying the 3 times table, because 3 times 1, 3 is standing alone. So 3 times 1 will give us what? 3. 3 times 2 will give us 6. So 3 times 2 will give us 6. 3 times 3 will give us 9. And then 3 times 4 will give us 12. So in this case, it can be in repeated multiplication. You are adding or you are multiplying by the number itself. Good. Alright, so we are going to skip count in 5s. So our first number is 5. You add 5 to the 5, what do we have? 10. We are adding another 5 to the 10 to give us 15. When we add another 5 to 15, we have what? 20. Another 5, so 20 plus 5 will give us what? 25. And it moves on like that, or it goes in that manner. Very good. Children, what have we learned today? Today we've looked at multiplication and the number operations. We've looked at how to solve multiplication sentences using the rectangular arrows, the vertical line, and then the horizontal line in finding answers for multiplication sentences. And then we looked at skip counting and multiplication. And then our last strategy was finding the answer of multiplication using the number line. Good. Children, try more examples using these strategies in multiplication, either the rectangular arrays or the number line, or you can do the skip counting. I'll see you all in our next lesson. Make sure you come on Zoom so that we have another lesson on what we have learned today. I'll see you all later. Bye-bye.